Mm, Today I am going to discuss new topic gravitation on the basis of the observation on planet and stars made by Tycho Brahe and his assistant Jonas Kepler presents three famous laws about planetary motion. The three laws of Kepler can be stated as first law of orbits, Kepler's first law. All planets move in a elliptical orbit with the Sun situated at one of the foci of the ellipse. This is the elliptical figure, and this point and this point is called focus of the ellipse, and this is semi major axis, and this is minor axis, and this is major axis, and sun is placed at one of the foci. Let's consider here it is sun, and planets moves in this elliptical orbit. When planet comes near the point P, it is called perihelion, very near to the sun, and when it comes to the point A, this is called aphelion. Now it is convention to take major axis from P to A as a 2A, and minor axis this line as a 2B. So from here to here distance will be A, or here to here distance will be A, and here to here distance will be B, or here to here distance will be B. Second law, laws of area, Kepler's, this is also called second Kepler's second law. The line that joins any planet to the sun shifts equal area in equal interval of time. This law comes from the observation that planets appear to move slower than they are farther from the sun than when they are nearer. The linear speed of a planet is greater when it is closer to the sun than its linear speed away from the sun. So this is the second law, and now we are going to talk about third law. Law of periods, Kepler's third law. Third law, the laws of period, Kepler's third law. The square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. If t is the time period of revolution of a planet and a is the length of the semi-major axis of it, then t square equals t square directly proportional to a cube. That is time a square of time period of revolution proportional to cube of major axis. So that the Kepler's law of constancy of aerial velocity is consequence of angular momentum of conservation. Question. So that the Kepler's law of constancy of aerial velocity is the consequence of angular momentum conservation. Here an elliptical orbit is shown to describe the Kepler's law of motion. Consider a planet whose radius vector r vector sweeps out an area delta a in time delta t. Here it is shown. This is a radius vector r vector which sweeps out, that is going in time delta t from this point to this point, and this whole area is delta a, and this displacement is delta r in terms of position vector. So because and so this will be this line, this radius vector will be r plus delta r. Now we know that area of triangle equals to 1 by 2 r vector into delta r. Since delta r equals to v vector into delta t, hence delta a vector equals to 1 by 2 into r vector plus v vector into delta t, or delta a vector by delta t equals to 1 by 2 r cross v vector, or 1 by 2m into r vector cross mv vector, and m will be cancelled, so we have 1 by 2m equals to, no, there is no need to cancel it, only change it to m into v vector becomes momentum vector, so 1 by 2m into r cross p, and r cross p is angular momentum, so we have L vector by 2m, so delta A by delta E equals to L vector by 2m, where m is the mass of planet, p vector is the momentum of the planet, L vector is the angular momentum planet. As the force governing the motion of the planet around the sun is a central force, and for a central force angular momentum of system remains constant. So from equation 1, the aerial velocity delta A by delta T is constant, proved. Now central force. A central force is a force that is always directed toward or away from a fixed point, that is along the position vector of the point of application of the force with respect to the fixed point. Further, the magnitude of a central force F depends on R, the distance of the point of application of the force from the fixed point, or F equals to Fr. Example, gravitational force and Coulomb force are central force. Newton steps towards law of gravitation. On seeing an apple falling from a tree, Newton was inspired to arrive at an universal law of gravitation that led to an explanation of terrestrial gravitation as well as of Kepler's laws. Newton assumed that the moon revolves around the earth in a circular orbit of radius rm. The centripetal acceleration is due to earth gravity, and given by am equals to v square by rm equals to 2 pi rm by t whole square into 1 by rm equals to 4 pi square rm square by t square into 1 by rm equals to 4 pi square rm by t square, where t is the time period of revolution of moon around earth, which is 27.3 days. So t equals to 2 10 27.3 into 24 into 60 into 60 in second, and value of rm at that time was already known to be 3.84 into 10 to the power 8 meter. Using these values in 1 Newton gate, am equals to 4 into 3.14 ka whole square into 3.84 into 10 to the power 8 divided by 27.3 into 24 into 60 into 60, which come out to be 2.72 into 10 to the power 3 meter per second square. This value is very much smaller than the value of acceleration due to gravity g on the surface of the earth, arising due to earth's gravitational attraction. This clearly shows that the force due to earth's gravity decreases with distance. Newton proposed that the gravitational force should be inversely proportional to the square of the distance. Thus, we have am proportional to 1 by rm square and g proportional to 1 by RE square. The situation is shown here. This is the earth and this is a moon which is revolving around the earth in a circular orbit, and this represents the distance between earth and moon, that is center of earth and moon uh, radial distance, and here on the earth surface A equals to G. Now G by AM equals to RM square by RE square, or RE square equals to RM square by AM by G. This implies RE equals to RM under root AM by G. Using known value, we get RE as a 3.84 into 10 to the power 9 into 0.273 into 10 to the power 2 equals to 3.84 into under root 0.0277 10 to the power minus equal to 0.6391 into 10 to the power 7, or 63 into 91 into 10 to the power 3 meter, which is about 64 kilometer, or 6391 kilometer, which is the closest agreement of the value of RE known at that time. This is close to the agreement of value of RE known at that time. So using gravitation law, Newton derived the radius of that is distance between moon and earth, and which comes out to be this value, and this value is very closest to the known value of earth distance between earth and moon at that time. Now Newton's law of gravitation. Every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the distance between and inversely proportional to the square of distance between them. A square of distance between them. Consider 2 points mass, let's say M1 and M2, placed at a separation of r. The force between them is mode of F vector equals to G M1 M2 by R square. There are 2 point mass M1 and M2 with a separation R. So force between these 2 point mass will be given by mode F equals to G M1 M2 by R square, where G is called universal gravitational constant. In a SI system, its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. The value of G does not depend on the nature and size of the bodies. It also does not depend on the nature of the medium between the bodies. That is why G is called universal gravitational constant. Now gravitational force in the vector form. Here situation is shown in the space or plane. There are two bodies, point mass m1 and m2 with position vector r1 and position vector r2, and this vector can be represented as r2 minus r1 using triangle law of vector addition. So force on 2 d21 is f21 vector equals to minus g m1 m2 by r square into r cap. This is the magnitude, and this is the r cap vector, because r cap vector is in this direction. So force on body 2, that is this body applies a force on this body and it is in this direction. So if the direction of r cap is in this direction, so minus r cap show the direction in this direction, or equals to minus g m1 m2 by r square into r cap into r by r, or minus g m1 m2 by rq into r vector, or equals to minus g m1 m2 by mode of rq into r vector equals to f vector c. Now force on 1 due to 2 is f12. This is the convention to write the symbol. that is force on 1 on by 2 is written as this equals to g m1 m2 by r square into r cap or g m1 m2 by rq into r vector, transforming r cap into r vector. So here will be as a previous example, and this will be rq, then we transform r cap into r vector, or equals to g m1 m2 by mode of rq into r vector, or minus of under vector minus g m1 m2 by mode of rq into r vector equals to minus f vector. Question 2. From 1 and 2 we see that f21 vector equals to minus f12 vector, that is force on 2 due to body 1 is inverse to the force on 1 due to body 2. Clearly the universal law of gravitation is constant with Newton's third law of gravitation. Consistent with Newton's third law of gravitation. Clearly the universal law of gravitation is consistent with the Newton's third law of gravitation. Force on a mass due to several masses. Consider there is a body m1 and there are several body m2, m3, m4. So force on 1 will be mass 1 f1 will be f12 vector plus f13 vector plus f14 vector. This represents force on 1 due to body 2, force on 1 due to particle 3 or body 3, force on 1 due to particle 4. Or this can be written as equals to g m2 m1 by r21 whole square into r21 cap plus g m3 m1 by r3 1 whole square into r3 1 cap plus g m1 m4 into m1 by r square 4 1 into r4 1. This is the magnitude. This all terms represent magnitude, and this is only used for direction. That is r direction is from 2 to 1. Here direction is from 3 to 1 and direction is from 4 to 1. That is now solve one example. Three equal masses of m kg each fixed at the vertices of an equilateral triangle ABC. A. What is the force acting on a mass 2m placed at the centroid G of the triangle? B. What is the force if the mass at the vertex is double? A is double. Take AG equals to BG equal to CG equals to 1 meter. It is given. The situation is shown in the figure. Three body is placed on the vertices of a equilateral triangle. Not equilateral triangle. And a mass of 2m is placed at centroid of the centroid G of this triangle. Then we have to calculate the resulting force. So resultant force will be F equal to FGA plus FGB plus FGC. That is force on G due to A, body at A, force on G due to body at B, force on G due to body at C. And this can be written as FGA J cap plus FGB into cos 30 minus I cap plus FGB into sin 30 into minus J cap. We have resolved into we have passed one we have fixed this point at origin, and so we are taking this value as FGB sin 30 minus J cap. Similarly FGC equal to cos 30 I cap plus FGC is equal to sin 30 minus J cap equals to FGA J cap plus solving this and finally we get uh, G into 2m square minus 1 by 2 G into 2m square equals to 0. Now B. when the mass at g is doubled, then same formula applying, fr is equal to fga j cap plus fgb cos 30 minus I cap plus fgb sin 30 into minus j cap plus fgc cos 30 I cap plus fgc sin 30 minus j cap, and putting all value g 2m into 2m by 1 square into j cap, it is putting all the given value. Finally we get 4gm square minus 2gm square into j cap, 2gm square j cap. That is resultant force is acting in y direction. Answer. Shell theorem. If a point mass lies outside the spherical shell sphere with a spherically symmetric mass distribution, the shell, sphere attracts the point mass as if the whole mass of the shell or a sphere were concentrated at its center. Let us consider this is a shell or a sphere, a spherical body or a spherical shell, and a point mass is outside this spherical shell. Then their force will be this shell will be considered as a point mass concentrated at its center. Okay, so force between the magnitude of force between these two bodies will be F equal to gm by r square. That is, this body attracts because the gravitational force is attractive force. So this body attracts it in this direction, and this body, this point mass or body attacks this body in this point mass, this direction. Now, second, if the point mass lies inside the uniform spherical shell, the gravitational force on the point M, point mass is 0. Now, if consider this is a shell M of mass M and the point mass is inside the spherical shell, then force between these two bodies will be, gravitational force between two bodies will be 0. That is Fm equals to 0. Question: is gravitational shielding possible? Gravitational shielding is not possible. If we place a particle inside a shell, the gravitational force on the particle due to shell is 0. If the shell does not shield the other bodies outside it, which exerts gravitational force on the particle lying inside it.